Okay.
All right. I think it's exactly 2, so let's get going. So first of all, thank you very much for everyone who's attending and listening to us instead of the keynote out there. So Michael and I are going to be talking to you about a fraud detection for mobile apps for banking, and essentially just take you over what the solution looks like. Obviously, there's no time to go into complete technical details of this. But first of all, so I'm a data science director for the Partner Catalyst team, and Michael here is...
I'm a solution architect out of the Data Insight COE, and we work together with an African customer, and this is the technical team.
Yeah.
And so obviously we could not all come on stage, but the credit goes to all of these people, including us.
Yeah. So this is actually, we're going to talk to you about actually a real customer project which we're to deploy it for this bank in Africa. So let's just quickly review about what is the challenge that we're trying to solve here. So fraud detection was one of the early successes of using sophisticated neural network technology, detecting fraud out there. Right now we're talking about a lot of sexy applications for AI, but fraud is still out there. It's still a big problem. Estimates is that in 2015 it was about $22 billion in credit and debit card losses. But while credit and debit cards fraud detection has solutions out there, or they're very successful, banks are also migrating towards new ways of interacting with their customers, specifically the mobile app platform as a way for accessing your accounts and moving money around. So there's estimates that about 800 million people use mobile apps, and the fraudsters are following that line. So what you're seeing is that a lot of fraud is moving towards this mobile app as people are getting better at capturing the credit and debit card frauds. And to the extent that there's about 100% year-over-year growth in losses due to access from the mobile platform. Now, banks have all kind of things. For instance, they authenticate you through sending a text message to your mobile phone when you're trying to do anything. But what fraudsters have figured out that through something they call a SIM swap, they can effectively steal your mobile number. So the fraudsters do this SIM swap where they steal somebody's number. So the authentication process of sending you a one-time PIN to your device goes to the fraudster, who's then authenticated, and they go wild and doing this. So how do you go about detecting fraud, right? Now, by the way, has anybody here received a call from their bank to say, is this transaction legitimate? Anybody out there? Yeah, see, almost everyone. Has anybody actually had fraud in their accounts? All right, very impressive. that does happen a lot, right? And it's and especially on these mobile apps, sometimes the actual customer takes the loss. So the first challenge you have with fraud is that it's very rare, right? So even though the losses are big, typically we're still looking at about 0.05% of all transactions. So in detecting it, the big problem is false positives. You need a sophisticated model that can sift out those things that look like fraud but aren't fraud. And then the other thing is so the way you detect fraud is through the behavior on the account. So any single transaction might look legitimate, but the behavior over time is what kind of gives it away that it might be fraud. And very specifically, fraudsters want to get access to money quickly. So very soon after registering, getting access to the account, they try and move a lot of money. The other is they try and maximize it. For instance, what we show on the right bottom there, this shows you the distribution on the amount of transactions, a particular type of transaction that allows you to generate a voucher that can be converted to cash, right? And as you can see, the dot on the right top there, that is the maximum amount, and almost 45% of the transactions that were fraud were for that maximum amount, right? So the fraudsters are clearly not just choosing a random amount, they're going for the maximum amount, they're trying to get money out as fast as possible. So the way you address fraud is you look at account at history over time, and then you take action on an account. So what you'll be seeing in our solution is very much built around this concept of how do you maintain state? How do you remember what's been happening with the entity, the account that's transacting, and then how do you then act on it? What kind of models do you build? How do you evaluate performance? All right, so let's go on to the architecture, and Michael will take over.
Okay, thank you guys. So I walk you through the high-level architecture, and I will then provide you with a couple of code snap-ins. So the high-level architecture was basically determined by the customer request that they had their enterprise service bus on premises, where they basically were putting in all the different kind of backend system information in a JSON format. So every logging happens over that ESB in a JSON format. That was a given request by the customer, and therefore we decided basically to move on from the data sources which were coming from the customer to ingest the data into Event Hub. From Event Hub, we basically, first try was Stream Analytics, second try, which we finally go with that architecture, was Azure Functions. Just let you know, Azure Function gives you the ability to make a serverless, basically triggered by Event Hub processing of something. So the heart of our solution is basically the Azure Function, which gives you, on the one hand, that kind of serverless functionality. On the other hand, you're also able to easily scale that whole thing out. And Azure Function is, I call it, the orchestration engine for the overall architecture. The second very important part is SQL. We're using Azure SQL. We're using their in-memory tables, precompiled stored procedures, and we're using DocumentDB and that kind of architecture for saving the raw data, which is JSON. And we're using Azure ML for basically scoring. And in the end, we're using SQL again to basically bring the whole result back to the on-premises solution. So let me a little bit drill down into different kind of capabilities. The first one I would like to do is the transformation to JSON. So let me zoom in a little bit to make it a little bit more readable. So the flow is the following. Everybody is familiar with Azure Function? Okay, so in the end you have a run, and that run is basically more or less the heart of the orchestration engine. Okay, originally we planned to use 3 event hubs and slice and dice the different kind of processing, and later on we realized that we're having some serialization issues with the different kind of Azure Function, and therefore we have now one Azure Function which basically is doing all the processing. Therefore the code looks a little bit still spaghetti code, but we will improve that one and we will share that one with you later on GitHub. Okay, so the first functionality is basically covered by the Azure Function, and the Azure Function then basically sends the data down to SQL Server, which is basically the step prepare, send, and retrieve. A short step is also saving the JSON file as a set to DocumentDB. Another step is basically the customer is still not clear if he wants to do the logging in SQL Server or with App Insight. Therefore, both is running at the moment. Then we're doing basically the call of the Azure ML. We're getting the results. We check the score. And the important thing, by checking the score, customer is able to set a threshold when it's fraud and when it's not fraud, because otherwise, can you still hear me? Because I have the feeling the mic's not working.
No, it's working.
Okay, perfect. And last but not least, we send that kind of information back to the ASP, and there the customer can then do a decision what he's gonna do. Okay, and keep in mind, it's all about an account and about transactions who are running an account. And these JSON files we are using can provide you with one or more transaction per JSON file. So you really have to do some iterations to figure out. So the first step is basically, now I have to switch zoom out again and then zoom in again. The first step is basically in getting a clear understanding what kind of transaction is coming in. We basically have set different kind of transaction type, and the first step, we basically explore the JSON file and getting out that kind of a transaction type. The second thing we are doing is basically that we save the whole thing via stored procedure into that SQL database. And the core thing here is basically this line of codes where we basically, on the one hand, after we have done some prep work, we're writing, but we're reading at the same time. And let me quickly share with you the stored procedure, what the stored procedure is actually doing, because this stored procedure is one of the key components. And in that stored procedure, as I said, it's precompiled. We first save any kind of transaction which is coming in, but it's only the first step of that stored procedure. The second step is basically creating a feature set table or updating a feature set table. We're doing a lot of group there and calculations. Basically to get a view on what's going on that account. Okay, so we're having a history, and this is another important information, that history goes over 7 days. After 7 days, we're using history tables to move that kind of information out. Why we made the decision to use a history table? Because we realized 7 days is a good way of getting an understanding and collecting the features to be able to predict if it's fraud or not. Basically, this was a process, an interactive process between the data scientist team and the people who built basically that extraction solution. Okay? In the end, the result, which is coming back, looks similar to that one. This is basically a feature table where we basically have different kind of features. And what happens with that feature table gets basically sent to Azure ML, and Azure ML is basically doing the scoring of that current transaction and tells us if it's fraud or not fraud. I would hand over now to Jakob again. And
do you want to show where the threshold gets checked or not?
yeah, but
Can do
you're
it later. That's okay.
here we are.
There we go. All right.
Okay.
Okay. So you got the flow. So essentially, what we do is we use SQL in order to kind of aggregate. So SQL sees all the transactions, and then we featureize by doing things like aggregating over 7 days, 1 day, 1 hour, things like total transaction amount, number of login attempts, all these other things, right? So and because it's doing in memory, this allows you to be very quickly, and I think we're up to over 300 transactions per second can be handled in this manner. So basically, when you then call out for the score, this shows you the published classifier that actually uses to produce a score. So what it does, it takes this feature set, which is this summary of a lot of activity that happened on the account, and returns back a probability that there is fraud on the account. Although it's on a transaction, we're kind of estimating, is this account in a state of fraud based on the behavior we've seen up to now. The one thing you'll see missing here is there's very little code in here that does any kind of featureization. And that's because all the featureization happens in the database. So it's a relatively simple experiment that actually produces the score. And what I want to show you is just so how do we train a model for the fraud detection? So the first thing I want to show you is that this is the experiment that's used to train the model. There are basically two things we need to deal with here. The first thing is that we have a very big imbalance between the fraud and the non-fraud, right? There's a very big class imbalance. So for instance, if you look here at you can see we've got 100 columns of various features that come in here. If we look at the actual fraud label here, you can tell that there's basically almost no fraud transactions. And this is after we already, in the database, we already sample down 10% we only take 10% of the legitimate accounts and keep all the fraud accounts. So we have to deal with this. And then of course the other is how do we evaluate so that we get an evaluation that's realistic for the type of problem we're following. So when we actually look at the flow, the modeling is pretty straightforward. We essentially take our data. What we do with SQL here is I actually create a feature that allows me to split by date. So we kind of, we create a new variable with whether or not the date is in the training time. This allows us to then do a out of time test when we split. So we split not randomly, but we split for the last month versus the prior months used for training. As we go down, I'll show you. This is a little trick I use just to upsample the fraudulent transactions. So again, when we split, we don't split randomly. We split on the tag, fraud or non-fraud. And what I've done here is I've simply multiplied the frauds by 4 by just using the add rows twice. And then on the non-fraud side, I sample them by 50%. So I get like an 8 times increase in the number of frauds. So once I'm done here, I end up with a distribution that's much more manageable. And it's still not, the thing with fraud is you don't need to get to like 50-50 on the good versus bad classes here when you try and classify. The classifiers work just fine with something that's just reasonable. In this case, you can see I'm almost 5%. So through all these, I've went from 0.05 to about 5% frauds. And that's enough for the model to train on and get a good result. But so here's the challenge. So now we go down. In this case, I've trained 2 models, a logistic regression and a booster tree. However, when you look at the evaluation here, you'll see that the evaluation, again, doesn't help us much, right? Because we still have only such a small fraction of frauds, you get pretty good accuracy by simply saying everything is non-fraud. So looking at typical measures such as accuracy, you're seeing here, 9.994 looks great, but it's not necessarily useful for us because we have so few frauds in the distribution. So what we've done here, and this is I'll show you code that we'll share, is we actually wrote a custom evaluation that takes into account how does a bank actually operate in fraud, and so you can generate metrics that are useful for comparing models into in terms of how banks actually do this. So what I've done here is I've actually taken the zip file and just by converting the data to CSV and then opening it up in a notebook, I've done this already for you. I've actually with the steps that happen in that R code for the evaluation for you. So if you actually go to this site, aka MS Fraud Performance, you can download all the R code that's used for this evaluation. Again, so what does a fraud manager care about, right? They could care about how much of the fraud do they catch, so how many fraud accounts actually get detected, right? Remember what they do is they get a probability. What they then have is they have a rule that says if the probability is more than X, I'm going to create a case, I'm going to tag this as potential fraud. And what they then do is they say, well, if I do this, where should I set my threshold? And what I care about is, well, I want to make sure I catch as much fraud as I can. I care about catching the fraud early. So, if there's 100 transactions happening, it doesn't help that I catch the last one. I want to catch one of the early ones. And the last thing is, well, what is the price I pay? I'm gonna have some false positives, right? I'm gonna alert some accounts that are not fraud, and how many people do I have to inconvenience for doing this? So what we do is the data that we ingest, I have a little SQL procedure that just takes the output from the Azure ML model and summarize it by account, timestamp, the amount, and the label and the score. We basically have to roll up everything to the account level and simulate what happens in real life, right? The transactions come in one after the other. If any one transaction scores high, I create an alert and I effectively take action on the account, right? I can kind of call the person, I can block the account and so forth. So what this R code does, you can look into it through manipulation of these transactions. I essentially create a summary table, and we'll go down here. This is things we don't have time for. That looks like this. So I basically roll up for every possible threshold that you can set for when above which you're going to call things fraud. I'm specifically interested in the number of fraud accounts that will get flagged, the number of non-fraud accounts that will get flagged. See, I don't know how to create a mirror there. And then things like the ADR here is the account detection rate. So how many fraud accounts had at least one transaction that scored above that threshold? The false positive rate is just how many non-fraud accounts then get tagged at the same time. So you can get the ratio for, is it like 1 in 10 or 1 in 20? And we're interested in things like the volume. Also of interest this year is this VDR signifies the value detection rate. So again, that's on one account. I have a series of transactions. If I catch the first one, I can probably catch like 90% of all the losses. If I catch the last one, I catch almost 0. And specifically here, what we're doing is we're interested in what if you can't act immediately. So there's code in here, and I'll just show it quickly, that essentially shows you if I can't act immediately, what's the effect of a delay of, say, 5, 10, 15 minutes. And what I do there is you'll see the assignment there, the score effective. We say you effectively have to work with the score that was available X minutes ago. All right, so just to show quite at the bottom, of course, a fraud manager, what they want to do is they want to get graphs where they can decide where should they operate. So this shows you the trade-off between the false positive rate and your detection. What this here shows you is the value detection rate. So at a given false positive, a threshold that gives you that false positive, what is the what is the fraction of the dollars you can connect? And you'll see as the delay gets longer, you lose the detection capabilities. And these are other performance metrics that a fraud manager might use. Okay, I think we're running low on time here. Basically, just quick summary. So what we have here, and you can get to the code for it, is an architecture that allows you to summarize, create that stateful model that summarizes the state for a particular entity, such as an account, or typically it could be the transacting or destination account, modeling methodology, and then very importantly, a way to evaluate your performance in a realistic manner, that the same way as that a fraud manager might evaluate his portfolio. Thank you. Any questions? Any questions? Have anybody? Good. Yes, one on the back. Yes. So, right. The question is, what did the client come to as a request? What we're showing here is an actual project that is, in fact, I think it's just gone live. It's a bank in Africa that had this problem about the mobile app fraud that they wanted to detect. So this was built for them, and it's going to be used to score real time. All right, I think we have to leave here, but thank you so much.